Hello and welcome to this learning video. In the last learning video we have seen how to find out differences of trigonometric function, exponential functions, but we haven't seen how to find out the difference of a polynomial. Okay, so here in this we will find what is forward difference of a polynomial of the type like ax squared plus bx plus c. But forward difference of polynomial you cannot easily find out, because to operate this forward difference operator on a polynomial, first you have to convert this polynomial into a factorial notation. So first of all we will see what is factorial notation, then we will see how a given polynomial can be converted or can be represented into a polynomial of factorial notation, and then only we can think of forward difference operator or delta of polynomial in factorial notation. Okay, so let us start with So what is factorial? A product of the form x into x minus 1 into x minus 2 up to so on x minus of n plus 1 is called a factorial, and it is denoted by x raised to n or x raised to n factorial. And how we gonna read this as? We will read this one as x raised to the power n factorial. Now as you can see here, two notations are there, this and this, but here in the problems that I am going to express a polynomial in factorial notation, I would be using this type of notation. Okay, so this is a factorial and it is denoted by this. In particular, x raised to 0 factorial is 1, x raised to 1 factorial is x raised to 2 factorial is x into x minus 1, x raised to 3 factorial is x into x minus 1 into x minus 2, x raised to 4 factorial would be x into x minus 1, x minus 2 into x minus 3. Okay, and so on. Okay, these particular factorials that I have written, this will help us in reducing a factorial polynomial into a simple polynomial. Okay, so this is in particular we have written. Now we have some note, and this note says delta of x raised to power n factorial is n x raised to n minus 1 factorial. Okay, now this is analogous to what? d dx of x raised to n is equal to n x to the power n minus 1. So delta operator in differences act as or equivalent to differential. So forward difference operator is equivalent to differential operator. So here you can write like this. This is equivalent to this. Okay, now we have seen for the derivative. Now there may be a integration as well. So what is 1 by delta, that is antiderivative of x raised to the power n factorial. This is x raised to the power n plus 1 upon n plus 1. Okay, so this 1 by delta, that is inverse forward difference operator, work as a integration or antiderivative. So this is equivalent to integration of x to the power n dx, which is x to the power n plus 1 upon n plus 1. Let me precise about this. This is not equal. I am saying this is equivalent to. Okay, there is a huge difference between equivalent and equal. Okay, now our next objective is to convert the given polynomial into factorial notation. Okay, so let us see here. Representation of polynomial in factorial notations. So in the how we represent a polynomial in factorial notation? So there are two methods to represent a given polynomial in factorial notation. The very first method is direct method and the second method is synthetic division method. So for the very first problem, I would start with direct method and then I will continue with the synthetic division method, and later on in each and every problem I will adopt synthetic division method because it is very easy and less time consuming. Okay, so let us see the problem on this representation of polynomial in factorial notation. So let us see the very first problem. Express x squared minus x plus 1 in factorial notation. So we will go with the direct method first. Direct method. So in direct method, what you need to do, you just need to write down this polynomial as it is. So you can write let x squared minus x plus 1 is equal to. As this polynomial is of degree 2, so the factorial polynomial in factorial notation is also going to be a polynomial of degree 2. So let us write it as a x raised to 2 factorial plus b x raised to 1 factorial plus c x raised to 0 factorial, that is 1. Okay, now what you need to do is you just say this is to be equation A. Okay, now you just write down this x raised to 2 factorial as x into x minus 1. So this is nothing but a x into x minus 1 plus b x raised to 1 factorial is x plus c. Solve this further, you would get a into x squared minus x a plus b x plus c, that is ax squared plus b minus ax, here x is common from these two terms, plus c, and in the left hand side we have x squared minus x plus 1. Now when you equate the coefficient of like terms, on equating the coefficients from both sides we get what we get. Here the coefficient of x square is a, here the coefficient is 1. So we get a is equal to 1. Here what we have, coefficient of x is b minus a, here the coefficient is minus 1, and here the constant term is c, here the constant term is 1. So here a is 1, c is 1, b is equal to a, that would come here, that would be what is it? This is 1, okay, come here, okay, that would 0. So b is equal to minus 1 plus a, and a is 1, So this b is equal to 0. Okay. Now a is equal to 1, b is equal to 0, c is equal to 1. So equation A implies x square minus x plus 1 is same as 1x raised to 2 factorial plus b is 0, c is 1 plus 1. So this is nothing but the polynomial in factorial notation. Okay. Now let's solve the same problem with the help of synthetic division method. So this is the next method, that is synthetic division method. So here what you need to do is, you just have to write down the same thing. Let x square minus x plus 1 is equal to a x raised to 2 factorial plus b x raised to 1 factorial plus c. Now after that what you need to do is, you need to write down the coefficient of this polynomial. What is the coefficient of x square? 1. Coefficient of x minus 1 and the constant term 1. Let us write 0 here. So we have 1 as it is. Write 1 as it is. 1 into 0 is 0. Minus 1, 0 is minus 1. Minus 1 into 0 is 0, 1. Leave the last term. Leave the last term. Now we have taken, this is x raised to 0 factorial. Now take this 1 and divide. Apply the synthetic division method. So 1 as it is. 1 into 1, 1. Minus 1 plus 1 is 0. Leave the last term. And then we have this 2. So this 1 as it is. No further terms. No need to do the calculations further. Now this is nothing but the coefficient of, this is nothing but the coefficient of x raised to 0 factorial. This is coefficient of x raised to 1 factorial, and this is nothing but coefficient of x raised to 2 factorial. Okay. So here the coefficient of x raised to 2 factorial is a is equal to a. This is b and this is c. Therefore x square minus x plus 1 can be written as a, that is 1, x raised to the power 2 factorial, b is 0, so no need to write down, and c is 1, so 1 x raised to 1 factorial, that is 1. So as you can see, whether you go by direct method or whether you go by the synthetic division method, you will get the same answer. Now the point of contention is which method to adopt. By looking at this problem in particular, you will find this is very easy. Okay, but this is for the quadratic. When you go for cubic, you go for x to the power 4, then the calculations are not that easy. But this method is going to be the easiest one. This will remain as easy as one can adopt. Okay, so I recommend you to prefer this method only. Now let us take 1-2 more problems with the help of this only. So let me write it here. Now we have more examples over here, you can see, and this example number 2 comprises of 2 problems which says express the following polynomials in factorial notations. One is this. So you have to first of all express this polynomial in factorial notation, and then you have to find out del 2 of y. Okay, because factorial notations, on factorial notations only you can apply this forward difference operator. Okay, so let us first of all do the first problem. Let y is equal to x cube minus 3x plus 3 is equal to a x raised to 3 factorial plus b x raised to 2 factorial plus c x raised to 1 factorial plus d. Okay, now do the synthetic division method. So what are the coefficients that we have? We have the coefficients coefficient of x cube is 1, coefficient of x square is not there, means its coefficient is 0, coefficient of x is 3 and the constant term is 3. Now take 0, last one. So 1 as it is, 1 into 0 is 0, 0 plus 0, 0, 0 into 0 is 0, 3 into 0, 0, 3. Leave the last term. Now divide by 1. So 1 as it is, 1 into 1, 1, 0 plus 1 is 1, 1 into 1, 1, so 1 plus 3 is 4. Leave the last term. Then divide by 2. 1 as it is, 1 into 2, 2, 1 plus 2, 3. Leave the last term. Divide by 3. 1 as it is. No further division is possible. So this is the coefficient A. This is coefficient of x square B. This is coefficient of x, that is C, and this is the constant term D. So you can write y is equal to, what is the value of A? Therefore y is equal to, what is this? A is 1. So this is x raised to 3 factorial plus B is 3, x raised to 2 factorial plus C is 4, x raised to 1 factorial plus D, that is x raised to 0 factorial coefficient, that is also 3. Okay. Now you got the given polynomial in factorial notation. Now you need to find out this del 2 of y. So how we can find out del 2 of y? So del 2 of y is equal to del of y. So you can find del of, what is del of y? Del of y means this. So del of x raised to 3 factorial plus 3x raised to 2 factorial plus 4x raised to 1 factorial plus 3x raised to 0 factorial. Now as we have written, note that this del operator works as a differentiation here. So what is derivative of x to the power 3? So that is 3x raised to 2 factorial. You write down in factorial notation, but think like a derivative. Second one would be 3 2s are 6, 6x raised to 1 factorial plus 4, x raised to 1 factorial is 1, delta of x raised to 1 factorial plus 0. Now apply this. So this is 3 times delta of x raised to 2 factorial plus 6 times delta of x raised to 1 factorial plus delta of 4 times, or delta of, you can write 4 delta of x raised to 0 factorial, that would be 0. So this is 3 2s are 6, x raised to 1 factorial plus 6 1s are 6, so this is 6. So del 2 of y comes out to be this. Okay, if you want in terms of polynomial, that also you can write 6x plus 6. Simple. Now I want you to solve this problem, or what I can do is I can express this polynomial in factorial notation and you find out this del 3 of y. Will it be okay? Okay, fair. Let me express this. Let y is equal to x raised to 4 minus 11x square plus 7 is equal to a x raised to 4 factorial plus b x raised to 3 factorial plus c x raised to 2 factorial plus d x raised to 1 factorial plus e. Okay, so what are the coefficients? Now see, here the term of x cube and x is missing, but it is not necessary that if the term of x and x cube is missing here, the term of x raised to 3 factorial and term of x raised to 1 factorial will miss. Okay, so whether the terms are here or not, there is a full possibility that you will get a term over here. Now let us first of all express this polynomial in factorial notation. Okay, so let us do this calculations fast. This is 0, coefficient of x to the power 4 is 1, then we have 0, coefficient of x cube, coefficient of x square is minus 11, then coefficient of x is 0 and the constant term 7. This 0 as it is, 0 into 0, 0, 0 plus 0, sorry, this 1 as it is, 1 into 0 is 0, then 0 into 0 is 0, this is minus 11 into 0, 0, this is 0 and this is also 0, so this is 7. Now 1. So this one as it is, 1 into 1 is 1, 0 plus 1 is 1, 1 into 1 is 1, this is 1, minus 11 plus 1 is minus 10, 10 into 1 is minus 10, this is minus 10. Okay, now divide by 2. This one as it is, 1 into 2 is 2, 2 plus 1 is 3, 3 2s are 6, minus 10 plus 6 is minus 4. Then we divide by 3. 1 as it is. 1 into 3 is 3. 3, 3, 6, 4, 1. So this is A. This is B. This is the value of C. This is the value of D. And this is the value of E. So you can write this y is equal to this as 1x to the power 4 factorial. Then B is 6x raised to 3 factorial. Then this is minus 4 x raised to 2 factorial. Then this is minus 10 x raised to 1 factorial plus 7. So I have expressed this polynomial in factorial notation. Now it's your duty to find out del 3 of y. Okay. So this is what we have in this learning video. If you have any doubt or queries, you can write down in the comment section. Till then, thank you for watching this learning video and enjoy learning mathematics. Thank you.